Okay, write down the topic hydrostatics. In this hydrostatics, we are studying the liquids in static motion. Static, there is not motion, static conditions, right? In dynamic condition, we studying it in uh, hydrodynamic, Bernoulli concept of. Okay, after this session, after this lesson, there is a hydrodynamics. Okay, we have to study what is the hydrostatics when the water body or the liquid body, what are the liquids, gases, and all are liquids. When the liquid body in the equilibrium, likewise we have to study the statics of the liquids. Okay, write down. It's known as that it's known as that matter exists as matter exists as matter exists as solid, solid, liquid, 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 and gases, and gases. Solid, liquid, and gases. Although a solid has a shape, a solid has a shape, but liquid and gases, but liquid and gases do not have do not have definite shape, definite shape, definite shape, definite shape. Hence, their behavior is their behavior is different to that of solid, different to that of solid, different to that of solid. Commonly, in next rule, commonly gases and liquids are called fluids. We have to study the fluids. In fluids are gases and liquids. Taken as are called fluids. Fluids. There are physical number of quantities. There are physical number of quantities of the important importance when identify fluid from one another. Fluid from one another. Fluid from one another. What are the parameters when we identify fluid? There is many parameters. After the final lessons, we also know the viscosity. Likewise, there is number of parameters, physical parameters, number of parameters. But when studying the hydrostatics, we are discussing some parameters when identify the liquids. Okay. Uh, we mainly focus fluid in static condition. We mainly focus fluid in static condition. Right. Write down another rule. Density taken, density taken, prominent, prominent, one of these qualities. One of these qualities. First of all, we have to consider the densities. Okay. One of these qualities. Okay. Write down the topic density. What mean by density? Mass of the substance in a unit volume is the density. We know. Okay, write down the topic density. Then write down the mass of substance. The mass of substance in unit volume. In unit volume is the density. Is the density. That means density equals mass over volume. Density rho equals mass mean M over V. Okay, write down. What is the dimension of rho? Find out. What is the basic unit of rho? Dimensions mean the dimension of M and L and V. Sorry, V. That means M. V means length into width into height. That means L3. ML minus 3. Basic unit is kg M minus 3. Other units. We can take GCM minus 3. These are the most common units we are discussing. So, if we using this, we have to get clarify what is the unit conversion. Unit conversion. Okay. Write down. Convert following units. Convert following units. Okay. What is in 800 kg M minus 3? What is in GCM minus 3? And find kg M minus 3 in GCM minus 3. 0.9 GCM minus 3. Find out in kg M minus 3. Okay. Find this 3 problems. Convert it. We have to use the unit conversion. Okay. What is the answers? For the conversion, let's take first one. It's very easy. chemistry in chemistry also you doing these things, right? 800 kg m minus 3. 800 kilogram m3. We have to convert into grams and it convert into centimeter cube. Okay. Therefore, we have to multiply it by 1000 to convert the gram. Meter to centimeter means 10 to the power 2. 10 to the power 2 and the 3. That mean what? We have to divide it into 800, 10 to the power 3, 10 to the power 6. Likewise, we have to divide it into 1000. 1000. Okay? 1000. Okay? 0.8 GCM3. Okay. Likewise, it also we have to divide into 1000. 13.6 GCM minus 3. Therefore, we can take the connection, no? If we have to convert kgm minus 3 to gcm minus 3, we have to divide it by 100, 1000. Then when we convert this one, when we convert this one, 0.9 gram cm cube, we have to convert this one. Therefore, zero point 0.9 gram means gram 10 to the power minus 10 to the power minus 3. Gram 10 to the power minus 3 gram. We have to convert into kilogram. Okay. Centimeter 10 to the power what? 10 to the power meter 10 to the power minus 2 cube. That means 0.9 divided by 10 to the power minus 3, 10 to the power minus 6. That means 0.9 into 10 to the power 3. That means 900 kg m minus 3. Right? 900 kg m minus 3. Therefore, for that case, we can build a relationship. What is that? When we want to convert kg m minus 3 to gcm minus 3, we have to divide it into by 1000. When we have to convert gcm minus 3 to kgm minus 3, we have to multiply by 1000. Okay. 1000. Okay. Okay, write down this relationship. Write down this relationship. Okay. Okay. Write down the relationship. Then write down this one. Then write down the density of fluid. The density of fluid using the star mark. Okay. Density of the fluid changes according to changes according to changes according to the temperature and pressure. The temperature and pressure generally density decreases with density decreases with the increasement of temperature. Decrease with the increasement of temperature. Why is that? In heat, the lessons, when an object having a mass and the volume, we know the densities. I telling the small small idea, getting the small idea. This is sufficient, but we discuss it in the volume expansion in heat, right? The mass and the volume is this one, mass over the volume. When we heat this object, the volume get expand. The volume get expand, right? Therefore, the volume get expand, the density getting decrease, right? අතෝ වතුර නෙමේ මොනවාද? අපි මොකක් හරි අර තේ එකක් ඔය හදනකොට ඒකෙදි density එක අඩු, ඒ කියන්නේ temperature එක වැඩි වෙනකොට density එක අඩු වෙනවා. temperature එක වැඩි වෙනකොට density එක අඩු වෙනවා. හරි. එතකොට අර යටට මිදෙන ඒවා තියෙන්නේ. උඩට රත් වෙච්ච ඒවා ඇවිල්ලා යටට මිදෙන පල්ලාට යනවා උෂ්ණත්වය අඩු එක. ඒ කියන්නේ temperature එක අඩු එක. Right? Okay. It's a small idea. We discuss in heat lessons. Okay. Volume expansion. Volume expansion. Right. Write down the topic. Another topic. Relative density. Write down the topic. Relative density. What is mean by the relative density? Relative to what? The density is relative to what? The density of the water. Relative density. Okay. Write down the velocity. The density of the substance. The density of the substance relative to the water. Relative to the water. Relative to the water is called relative density. Is called relative density. Relative density. That means the symbol is D. Density of fluid over density of water. This is the relative density. That means D equals rho over rho W. Rho equals D rho W. Find out the dimension of D. Dimension of D. Find out the dimension of D. Yes. There is no dimension. There is no dimension and no units. Right? Why? ml minus t, ml minus t, 1. Write down. There is no dimension and no units. So, no dimension and no units for relative density. Relative density. Okay. Relative density. Okay. Write down the problem. It's very easy concept. Huh? Write down the problem. Since the relative density okay, not a problem. Write down as a point. Write down as a point. Since the relative density point, since the relative density is a ratio of The density is the density, and the density of the water is 1000 kg m minus 3. Density of the water is 1000 kg m minus 3. The density of the fluid, the density of the fluid can be obtained in SI units, can be obtained in SI units by multiplying the relative density by 1000, by 1000. That means d rho w, d into 1000, 1000 d density is this one. Okay. Example. The density of the mercury, density of the mercury 30,500 kg m minus 3, 30,500 kg m minus 3. Find out the relative density of relative density of relative density of find out the relative density of the mercury. Relative density of the mercury. Okay, find out. Quickly find out. $13,500 divided by 100 kg. That means 13.5. This is bit similar to the what when we represent this in GCM minus 3, that also get in the same value. Same value. Therefore, we can tell when we represent some density in GCM 3 value, GCM minus 3 value, we can take the relative density as it is, right? Then write density of mercury in GCM minus 3. 13.5 GCM minus 3. Bit similar. Okay. Then write if the mass of volume capital V, the mass of volume capital V, mass of a volume capital V is the substance is mass of volume capital V of substance simple M, and the mass of the capital volume of the water is MW, is MW, relative density what? Density of substance over density of water. That means density of the substance mean M over V. Density of the water mean MW over V. Okay. We can cancel out this one. M over MW. Right. That means when we write in as a sentence, relative density is the mass of given volume of substance over mass of given volume of water. Okay. Okay. Write down this one. Draw this one and write down this one. Draw this one and write down this one. Is that okay? Good. Then write down. Then write down the table. The table shown below. The table shown below shows the density of few fluids. Density of few fluids. Density of few fluids at a pressure 1 atm. At a pressure 1 atm. Atmospheric pressure. And temperature 4 seconds. And temperature 4 seconds. Why 4 seconds? Normally, in 4 seconds, the water get its maximum density. It is 1000, right? There is a expansion in water. There is a not uniform expansion in water. We discuss in fluid expansion in that in liquid expansion. We discuss in the heat lessons also. There is no uniform expansion in the water. The expansion, the density is very high in 4 centigrade of water. 4 centigrade of water, right? That's why we are taking 1 atm and 4 centigrades. The 1000 get in the 1000 the density is 1000 in 4 centigrades in the water, right? Where is table? Okay. First column liquids density in kgm minus T, density in gcm minus T, relative density. Mercury. Draw this diagram. Mercury, water, sea water, volatile, oxygen. Okay. Write down this one. Write down this. The density 13,600 kgm minus 3, water 1000, sea water 1003, coconut oil 800, 1.43, 0.09. Complete this one, the diagram. Complete the graph. Okay. Complete the graph. For this case, the density in NCA minus 3, 13.6, 1, 1.03, 0.8, 1.3 mean 1.43 into 10 to the power minus 3. 9 into 10 to the power minus 5. Okay. I told the relative density mean the density of the substance divided into the density of the water, right? In 4 centigrade, the density of the water is higher. It is 1000, right? There, it is 1000. Therefore, when we divide it into this one, it got 13.6. That also same value. Same value. Okay. This is the graph. Okay. Then write down the another subtopic. Write down the another subtopic. We are discussing densities. Huh? We are discussing densities. Write down another subtopic. Write down another subtopic. Density of mixtures. Density of mixtures. Okay. Simple A part. Simple A part. A mixture according to volume. You know these things. In some bottles, there is a ratios. There is a ratios that mean T 30.7 VV. In some bottles, there is a VV ratio. That means volume to volume. Volume to volume. Volume ratio. This calling the volume ratio. Volume between the liquids. Volume ratio. Right? Okay. Write down. Let's take the volume ratio. Let's take the formula. I take in the V1 volume from this fluid V1, and I take in the V2 volume from this. Both when we add in both of them, the density of this one we have to find density of this one, right? That means the mass of this one is equals what? Mass equals to rho equals MOV mass equals to rho into V, right? Therefore, mass equals to rho 1 V1, mass equals to rho 2 V2. We added we adding them into this and we mix them. The volume ratio, find out the volume ratio. We have to take the volume ratio, or we have to take the density of the mixture. Right. Okay, write down. If a volume of capital V1, if a volume of simple V1 of substance of liquid which having density rho1, which having density rho1, which having density rho1, mix with volume V2, mix with volume V2, simple V2 of substance which having density rho2, rho2. Right. This is the case. Okay, write down this. The mass is this one. We add in the volume. V plus 1, V2. Okay, write down. How can we find the density of this mixture? How can we find the density of these mixtures? We have to find the density of this mixture. How can we find the density of the mixtures? Okay. For that, we have to find out the total mass and the total volume of the mixture. Total mass and the total volume of the mixture. Okay. I take in the total volume of mixture. What is the total volume of the mixture? Total volume of the mixture. What? V1, V2. We are adding them. Therefore, total volume of the mixture is what? V1 plus V2. V1 plus V2. Okay. Total volume. What is the total mass of mixture? What is the total mass of the mixture? Total mass. Total mass mean this is M1, M2. Adding them, that mean M1 mean rho 1 V1 plus rho 2 V2. Rho 2 V2. Rho 1 V1, rho 2 V2. Right? Rho 2 V2. What is the density of the mixture? Therefore, density of mixture equals total mass of mixture over total volume of mixture. Total mass of the mixture mean total mass rho 1 P1 rho 2 V2 over total volume of the mixture mean V1 plus V2. This is the density of the mixture. This is not a formula. We have to take this formula. It is very easy. Total mass divided into total volume. Okay. Total mass divided into total volume. Right? Write down this one. Only you have to memorize density is the mass or volume. Total mass, get the total mass, get the total volume. It's very easy. Okay. Okay. When we mix the equal volume, when equal volume are mixed. When equal volume are mixed, we can take P1 equals P2. V1 equals V2. I take V1 equals V2 equals V. Okay. The density rho equals rho 1 V, rho 2 V, V plus V. That means rho 1 V, rho 2 V over 2V. V cancel out. Therefore, we can take the density as rho 1 plus rho 2 over 2. Adding them and divide it by. Okay. Write down this one. When we use in the mix with the same volumes, we can add them together and divide in 2. Okay. Divide into 2. It's very easy. There are two types of mixtures, volume mixtures and mass mixtures. So the volume mixtures, there is a also you also see there is a bottle some containing the chemical bottles or alcohol bottles or all things containing VB volumes. VB percentage mean the volume of volume. That means the volume percentage. Volume percentage. Okay. That means the volume of the mixtures. Okay. Write down this one. Okay. Then part B, a mixture according to the mass. Part B, a mixture according to the mass. Write down part B, a mixture according to the mass. Okay. Let's take that also. Okay. Then let's take like this. We take the liquid which find the density rho 1. We take the mass M1 from this. Then we take the another liquid, it having the rho 2. We take the mass M2 from that. M1 and M2. So after the mix, the mixture can be the density of mixture rho, mass equals M1 plus M2. We have to find the rho value. Rho value using the these M1, M2 and rho. Right? We have to take the rho value. Okay. Okay. Write down the topic a mixture according to the mass. Then write down. Write down the mixture of the mass. Then write down if a substance of if a mass of simple M1 from a liquid which having density the mass of simple M1 from a liquid which having density ρ1, ρ1, ρ1 is mixed with the mass M2, M2 which having density ρ2, ρ2. Right, as follow. Okay, write down this one. Draw this one. Draw this one. Separately, we have to take all the values. Okay. Let's take as previous. Previously, we discussed through the mixture of the volume. Likewise, we have to take. Okay. Okay. What is the total volume of the mixture? Can we get the total volume? No, that's a difficulty because we know the mass and the density. Density equals mass over volume. Volume equals mass over density. Mass over density. Therefore, mass over density means the V1 we can take as what? V1 equals mass over density. V2 equals mass over density. Okay. Okay. You know, it's very easy. Huh? We have to take the volume as mass over the density. Right. Then we can move total volume of the mixture. What is total volume of the mixture? V1 plus V2. That means M1 over ρ1, M2 over ρ2. Okay. Total mass of the mixture. What is the total mass? M1 plus M2. M1 plus M2. Therefore, density of the mixture is total mass of the mixture M1 over ρ1, M2 over ρ2. Total volume of the mixture. Sorry, total mass of the mixture is M1 plus M2. Total mass of the mixture is M1 plus M2. Total volume means M1 over ρ1, M2 over ρ2. Right. This is the equation. This is the equation. Okay. Write down that one. Find out the when equal masses are mixed. That means M1 equals M2 equals M. What is the value? Find out that one. For this case, rho equals what? M plus M over M over ρ1, M over ρ2. Okay, we have to substitute that things. M, 2M, 2M and M over ρ1. We can take the M as constant. ρ1, ρ2, ρ1 plus ρ2. Sorry. It's not clear in this area. I shift it into this. I take this one. Rho equals 2M M 1 over rho1, 1 over rho2. This one. Cancel out. Cancel out. Then what? Then 2, 1 over rho1. We can take rho1, rho2. Rho1 plus rho2. Rho means 2 rho1, rho2 over rho1 plus rho2. This is the answer. This is the answer. Okay? Very easy. Okay, write down that one. Okay, write down that one. Okay, write down the final problem. Write down the problem. I think it's okay. No? These are not formulas to memorize because only we have to do things is mass density equals mass over the volume. We have to find the total mass and the total volume. That's only the thing. We have to do not memorize to these equations. These equations are not in use, useless. We don't use the equation. We only use the mass density equals mass over the volume. It is very easy. That's the concept. Okay. Write down the problem. A substance, uh, uh, a substance, rho1 equals 8000 kg minus 3 is mixed with rho2 12,000 kg minus 3 12,000 kg minus 3 is mixed with rho2. The final density 9,000 kg minus 3 9,000 kg minus 3. Find the ratio in which mixed by number 1 volume, number 2 mass. This one and this one mixed with each other, then we produce the this one and this one mixed with each other and produce the rho final 9,000 kg minus 3. Find the volume ratio V1 over V2 and mass ratio. Find out. So we have to find the volume ratio. I take in the volume B1, the density 8000, and the volume B2, density 12,000 are mixed. Then I got the mixture. This having V1 plus V2 and the density of rho. That equals to the what? This is equals to the density of rho final mixture equals to the 9,000. Initially, I also told there is no formulas. We have to take the only the values. Okay. Let's take total mass. What is total mass? Mass equals rho 1 V1. What? Rho 1 V1 rho 2 V2. Mass equals what? Mass equals to mass over volume equals rho. Mass equals rho V. Like that. This one. Total volume. V1 plus V2. Total volume V plus 1 plus V2. Okay. Then the density is 9,000. Total mass mean rho 1 V1, rho 2 V2. I substitute this one rho 1 as what? 8,000, 12,000. Okay. Total mass over total volume. 9,000. Total mass mean 8,000 V1, 12,000 V2. Total volume means V1 plus V2. V1 plus V2, 9,000 equals 8,000 V1, 12,000 V2. Cancel out these 3 zeros. Divide by in 1000. 9 V1, 9 V2 equals 8 V1, 12 V2. Therefore, this come into this side. 9 V1 minus 8 V1 is goes to this direction. 9 V2, 12 V2, 9 V2. That 3 V2 equals 1 V1. Therefore, V1 over V2 means 3. Volume ratio V1, V2 volume ratio is 3 to 1. 3 to 1. Okay. Good. Your answer is correct. Right? Then we have to find out the mass ratio. M1, M2, M1 plus M2. Total mass mean M1 plus M2. Normally M1 plus M2. M1 plus M2. Total volume, but we have to get the volume. How can we find the volume? Volume means rho equals mass over volume. Volume equals mass over rho. Right? M1 over rho 1, M2 over rho 2. That means M1 over 8,000, M2 over 12,000. Okay. Then we have to move this to these things. 9,000 equals total mass. Total mass mean M1 plus M2. Total volume means this one. M1 over 8,000, M2 over 12,000. We have to multiply them. I transfer this one to this direction. Right. That means M1 over 8,000, M2 over 12,000 over 9,000 equals M1 plus M2. I take this one to this direction. Therefore, I can cancel out these zeros. Why? They are also 10 to the power 3. They are also 10 to the power 3. We can cancel out. M1 over 8, M2 over 12. I get in the common. What is common? We can take the 24 as common. M1 M1 mean 3M1 2M2 into 9 M1 plus M2. Okay. I take this is 3 and this is divided by 3, that means 8. Right. That means 3M1 2M2 3 8M1 M2. Right. That means 9M1 6M2 equals 8M1 8M2. Okay. Okay. We can get I take this one 9M1 minus 8M1 8M2 minus 6M2 2M2 1M1. Okay. Then M1 over M2 means 2. M1 M2 ratio is 2 to 1. Okay, this is the ratio. Okay, this is the problem. Okay, this is the problem in mixtures. Okay,